Hello, I want to talk about operating system topics. So today, I'm going to organize computer's overall structure from a really big picture view. To understand an operating system, there is something we need to understand first. What exactly is each part going to do inside a computer? I think understanding the computer structure makes me clearly understand why an operating system is necessary at all. So today, I want to explain the overall computer structure by comparing it to a restaurant kitchen. Actually, a real computer and a real kitchen are not exactly the same. It's just a simple analogy to make the big picture easier to understand. So the way I currently understand it is like this. Your computer doesn't work just because it has a CPU. There must be RAM, storage, motherboard, and if necessary, it also needs network hardware. Different parts exist, and each part has its own role. Let me compare this one to a kitchen. A kitchen does not work just because there's a shelf. You also need a counter so that you can use the ingredients immediately. And you need a fridge or a storage room so that you can keep ingredients longer. You need some way to receive orders, and you need some system that keeps the whole kitchen organized. A computer is similar. From the outside, it looks like you open just one application. Just behind that, many kinds of parts are working together, and each one is doing a different job. Let me start to talk about CPU. We usually say that the CPU is the brain of the computer. In the kitchen analogy, it's like the main chef who actually does the cooking. The important point is the CPU is not merely for long-term storage. It's kind of part that handles the work happening right now. For example, when the chef is making pasta or fried rice, the actual action is done by the chef. The chef is gonna cut, mix, heat, check the order, and decide what to do next. And CPU is similar. It reads instructions, calculates, makes decisions, and processes what's gonna happen next. So, the CPU is the center of actual execution. No matter how good the program is, in the end, the CPU is the part that's really running. Okay, let's get into the next, RAM. A lot of people fear this one is confusing, but I think RAM becomes much easier if you think of it as a kitchen counter. Even if the kitchen has a lot of ingredients in the storage, a chef usually doesn't every time walk into a storage. Instead, the chef is gonna bring it out and put them on the counter. Maybe onions, meat, sauce, a knife, a pan, and a cutting board. The counter is a nearby workspace. RAM is similar to that. It's a fast working area where the CPU can really quickly access the data. In other words, RAM is a place where the things currently being used are temporarily placed. And one important point is this, RAM is fast, but it's limited. A kitchen counter also has limited space. The counter is too small. You can't place everything there. You only bring out ingredients for current work. RAM is the same. It's really fast but limited. So the system tries to keep important and currently necessary things there. Now let's talk about storage. By storage, I mean something like an SSD or HDD. It's more like the fridge or storage room in the kitchen. RAM is a counter and storage is a long-term storage area. Programs, photos, documents, games, operating system files, everything's gonna stored here. For example, when a chef needs to cook pasta, the ingredients are not already on the counter forever. They're usually in the fridge or storage room first. The chef brings them out when it's necessary. A computer is similar. When you run a program, that program is usually stored on the disk first. Then, when it's executed, some of the necessary data is gonna be loaded into the RAM, and the CPU starts processing it. So let me summarize. and storage keeps data for a long time. RAM temporarily keeps data that is necessary right now, and the CPU actually does the work. And what is the motherboard? I think of the motherboard as an overall physical kitchen structure, the layout, the connections, and the basic infrastructure. The shelf, the counter, and the fridge. If there's no connection and it's all separated, they're gonna be useless. So everything has to be connected, and computer is the same. The CPU, RAM, storage, graphics card, network hardware, all of them have to get a system where they communicate with each other. The base structure is the motherboard. Actually, it does not directly do those main calculations, but without motherboards, the different parts cannot work together. So the motherboard looks least dramatic, but it's a foundation that supports the whole system. And I'm gonna talk about network hardware. In the kitchen analogy, it's like a connection between the kitchen and the outside world. For example, the elevator order comes in, it's like some overage, a payment system receives requests, and the restaurant communicates with another branch. There needs to be some way to connect with the outside. In a computer, network hardware allows the machine to communicate with the internet or with other computers. Your computer does not only calculate things by itself, but it also opens websites, sends requests to servers, downloads files, and communicates with game servers. And let me summarize again. The CPU handles internet processing, RAM is an internet workspace, storage is an internet storage room, and network hardware is like kind of connection between the system and the outside world. Now at this point, an important question appears. If all of these parts exist, does the computer automatically work in a clean and organized way? Absolutely not. In a kitchen, you may have a shelf, a counter, a fridge, and incoming orders. But what if there is no control at all? What happens? Several shops may try to use the same tool at the same time. Nobody knows which order should be done first. Ingredients get left everywhere. The order of work is getting messy, and the whole workflow starts breaking down. That's exactly the reason why operating system is necessary. The operating system, OS, is like the kitchen manager who keeps the whole place organized. Sometimes, people think of the operating system as just another program. Actually, yes, it's a software, but its role is really special. It's gonna decide who uses a CPU, how memory is used, how files are handled, and how devices are communicating with each other. In the kitchen analogy, the operating system does things like this. It decides which order should be cooked first. It controls how the limited counter space is used. It helps manage who gets access to ingredients. It keeps delivery orders, takeout orders, and dining orders from turning to total chaos. In other words, the operating system is a resource manager of the computer. Let me say that in a more realistic way. When we use a computer, it looks like many programs are running at the same time. We open a browser, listen to music, use a messenger, edit documents, and maybe download some files too. From the outside, it feels like the computer is doing everything at once, but the CPU has a limited attention at any given moment. So somebody has to manage who gets CPU time, who needs to wait, who uses memory, who reads some data from disk, and who sends data over the network. That operating system is gonna manage everything. So without an operating system, the whole computer would become much more disorganized. Let's also look at the flow about running a program. And let's say that we open a browser or a messenger application. That program is originally stored on disk, and the kitchen and knowledge is stored in fridge or storage. But when we press run, the operating system prepares it so that it can actually run. It brings some necessary parts from the disk into the RAM, so the CPU begins working on them. In the kitchen and knowledge, it's like taking ingredients and a recipe out of storage and placing them on a counter so that the chef can start cooking. Then the CPU begins processing the instructions one by one and the program starts running. Sometimes during the process, the program needs to read more files from storage or receive data from the internet through the network. So program execution does not come from nowhere. Something stored on the disk is brought into the RAM. The CPU processes it, and the operating system manages the whole process. And I want to summarize today's idea. It'll be like this. A computer is not a system where the CPU does everything alone. The CPU handles processing. RAM is a workspace. Storage keeps data long term. Network hardware connects to the outside world. The motherboard provides a foundation and connection path. And the operating system manages the whole system. The big picture has to be clear first, and then later topics are gotta make sense. For example, when we later study processes, we can understand that the operating system is managing running units of work. When we study scheduling, we can understand that it's about deciding who gets CPU time and in which order. When we study memory, we can understand that limited workspace must be used efficiently. And when we study virtual memory, we can understand that because RAM is limited, the system needs additional structures. So today's topic may feel basic, but actually, this is the starting point for understanding the whole operating system. So in the end, the operating system is the one that keeps the whole computer organized. It manages the CPU, memory, files, and devices so that all of them are gonna work together properly. So today, I wanted to organize the overall structure of computer from big picture view. Of course, a kitchen knowledge is just simply a way to understand the idea. So today, this was my attempt to organize what I learned about computer structure. If I got something wrong, please feel free to let me know in the comments. And I really appreciate you watching this video until the end. Thank you. Bye bye.